In this video, we are looking at how we can find the derivative of the function we have over here. Now, this function involves fraction, and some part also involves radical function. Now, the radical part of this function is square root of x. Square root of x. Now, before we can differentiate it so easily, there's the need to write the fractional index of the square root of x. So the fractional index of square root of x is equal to x to the power half. So the function becomes y equals 2 over x, 2 over x plus 1 over x to the power half. Now, once again, we need to simplify this, the fractions. Now, before we can find the derivative of this function, we need to move the variable x at the bottom to the top, that is from the denominator side to the numerator side. And as we move it from, or we move them from the bottom to the top, the exponents of their signs has to, the signs of their exponent has to change. So this is to the power 1. So as it moves to the top, the 1 changes to negative 1. And this one is to the power half, positive. So as it is moving from the bottom to the top, the exponent half will change from positive to negative half. So let's do that. So the function y equals 2x to the power negative 1 plus x to the power negative half. Now you may ask, why didn't I multiply 1 by x to the power negative half? Now 1 is a multiplicative identity. It means any number to multiply by 1 is the number itself. It will never change it. So that is it. Now we can now go ahead to differentiate. Once again, to differentiate this function 2x to the power negative 1 and x to the power negative half, we multiply the exponents by the coefficients of the variables here, which is x. So we multiply the exponent, which is negative 1, by the coefficients of x. So over here is 2. So we multiply. And then also this exponent, which is negative half, we multiply by the coefficients of this x. So we multiply. And we know that the coefficients of this x is 1. Alright? It's 1. So we have here dy dx equals to, now 1 times negative 2 gives us negative 2x. Now the exponent here has to reduce by 1, so negative 1 minus 1 will give us negative 2. And then also negative half times the 1 here will give us negative half x. And then negative half, as the exponent has to reduce by 1, so negative 1 or negative half minus 1 will also give us negative 3 over 2. So negative 3 on 2. Good. Now we can, let me repeat the function here, or the derivative here. So dy dx equals to negative 2x to the power negative 2 minus half x to the power negative 3 halves. Alright, so with this, we want to make the exponent of the x in both terms positive. So we need to move them from the top to the bottom so that they becomes positive. Now remember, this is over 1 and this is also over 1. So what we are going to do is that we are going to move the x to the power negative 2 and x to the power negative 3 on 2 to the bottom here, so that the signs of the exponent will change from negative to positive. Alright, so dy the x equals negative 2 all over x to the power 2 minus 1 over 2 x to the power 3 halves. Alright, so that is what we have as a derivative of the function 2 over x plus 1 over square root of x. Now you can move ahead. Remember, we can simplify x to the power 3 on 2. Now remember, from indices, a to the power m over n can be written as, now what we do is that we are going to factor the m out, so we are going to get a to the power 1 over n, then the m will come here as another exponent. So that is the situation we find this x to the power 3 on 2 here. So it means this x to the power 3 halves or 3 on 2 can be written as x to the power 1 on 2, then I'll bring the 3 out. So I've factored the 3 out, leaving 1 on 2. So this function here can be written as that. So let's move on with that. Therefore, the y dx is equal to negative 2 all over x squared minus 1 over 2 in bracket square root of x, square root of x to the power 3, x to the power 3. Okay,